Our first variation is where we have 3 x-intercepts. And the formula would be y is equals to a times x minus x1 times x minus x2 times x minus x3, where x1, 2, and 3 represent the x-intercept values. Our second variation is where we have a stationary point on the x-axis. So we only have 2 values of x as intercepts. Notice it looks the same as the previous equation. So y is equals to a times x minus x1 times x minus x1 times x minus x2. And x1 is repeated, and the point that is repeated, or the value of x that is repeated, is the turning point. So I can also rewrite this as y is equals to a times x minus x1 squared times x minus x2. Our third and final variation is one where there is no local minimum and maximum points, and we simply have y is equals to a times x plus p cubed plus q, and the coordinate of p and q would be given on the graph. Here's our first example. We are given 3 x-intercepts of -1, 2, and 3, and we're also given a point on the graph, 1 and 12. Now -1 would be x1, 2 would represent x2, and 3 would represent x3. So the equation that I can use is y is equals to a times x minus x1 times x minus x2 times x minus x3. And I substitute the values of -1, 2, and 3 into the equation. Notice, when I substitute a negative value in the place of x1, it is -1, and it will become +1. x2 is the value of 2, so it's x minus 2. And x3 is the value of 3, so it's x minus 3. Now don't multiply out yet. We first want to find the value of a. So I've used x1, x2, and x3. Now I need to use the x and y values in the coordinate given to me to solve a. So I substitute the coordinate of 1 and 12 into the equation. So the y value is 12. All of the x's is replaced with a 1. I simply multiply out, divide by 4, so the a value is 3. Therefore, the equation is y is equals to 3 times x plus 1 times x minus 2 times x minus 3. But this is not the standard way in which we write a cubic function, so we need to multiply out. I chose to multiply the last 2 brackets with each other first. So I have x minus 2 times x minus 3, which will become x squared minus 5x plus 6. And then I multiply x plus 1 with x squared minus 5x plus 6. And I get x cubed minus 4x squared plus x plus 6. Remember, I multiply x with all the values in the second bracket, and I multiply plus 1 with all the values in the second bracket. I add up like terms, and that's where I find this expression. Lastly is to multiply the 3 with all of the terms inside the bracket. So my final answer is y is equals to 3x cubed minus 12x squared plus 3x plus 18. And that is the equation of the given graph. In our second example, we are given -3 and 4 as a coordinate on the function, and we are given the turning point of -2, and we are given that 1 intercepts the x-axis. So the equation that I would use is y is equals to x minus x1, x minus x1, x minus x2. The -2 value would represent x1 because it's the turning point, and 1 would represent x2. So the first thing that I do is I substitute x1 with -2. So it's x minus -2, which becomes x plus 2. Same for the next bracket. And the last bracket, I have x minus 1, and that'll become x minus 1. Now I need to find the value of a. So I've used the -2 and I've used the 1. I'm now going to use the coordinate and substitute the x and y value of the coordinate into the equation in order to solve a. So I replace y with 4 and all of the x's with -3. This -3 represents that one -3 given there. I multiply out, and I find that a is equal to -1. Therefore, my equation is y is equals to -1 times x plus 2 times x plus 2 times x minus 1. So I multiply out. I multiplied x plus 2 with x plus 2 to get x squared plus 4x plus 4. And lastly, I multiply this whole expression with x minus 1. My final step is to multiply -1 with each term in the bracket. Therefore, the equation of the given graph is y is equal to -x cubed minus 3x squared plus 4. In my third example, I'm given a function. I'm given a point on the function of -1 and -2 as a coordinate on the graph, and I'm given -3 as the y-intercept. Now the p and the q value would represent the point of inflection in the graph, and this will be given as the point of inflection. So the instruction would say, or the information on the graph would read as, in the given graph, -1 and -2 is a point of inflection of the function. -3 is the y-intercept. Determine the equation of the cubic function. And what we need to do is use this format. So y is equals to a, and in brackets, x plus p to the power of 3 plus q. Now this works the same as in the quadratic function which you learned in grade 11. So if I have a point of x minus 1, I need to move that 1 over to have x plus 1 in my bracket. So my bracket here would be y is equals to a times x plus 1. So remember the sign of the x change. The q value is simply -2. Now to find the value of a, I need to substitute a coordinate in. And I've already used the -1 and -2 for my p and q values. Now I need to use the -3 in order to solve a. So at that coordinate, y is equals to -3, and because it's the y-intercept, x is equal to 0. So I can solve a, and a would be -1. Therefore, the equation of that function is y is equals to -1, x plus 1 to the power of 3 minus 2. You do not have to multiply this out, because the question would normally state, leave your answer in that format. In our last example for this lesson, we have fx is equals to ax cubed plus bx squared minus 12x. We are given the point of -2 and 20 as a stationary point on the function, and the question is to determine the value of a and b. So the function that I'm given is y is equals to ax cubed plus bx squared minus 12x. It's simply the fx function rewritten, and I replaced fx with y. The first logical thing to do is to substitute this coordinate into the equation. So y would be replaced with 20 and x would be replaced with -2. When I simplify that, I have 20 is equals to -8 plus 4b plus 24. So now if I put the values on the left and the constant values on the right, I get 8a minus 4b is equal to 4. And I can divide everywhere by 4. So I have 2a minus b is equal to 1. That is now my first equation for a and b. To find the second equation, I need to find the first derivative. Remember, at this stationary point, the first derivative is equal to 0. So I have a 0 value there, and I also have the x value, which is -2. So if I find the first derivative, it is 3ax squared plus 2bx minus 12. And I know that it is 0, so the gradient is 0, where x is equal to -2. So I replace x with -2. I multiply out, so I have 12a minus 4b is equal to 12. And I can also divide everywhere by 4. So I have 3a minus b is equal to 3. Now I have two equations. 2a minus b is equal to 1, and 3a minus b is equal to 3. And I can solve a and b simultaneously. In this example, I used the method of elimination, but you can also use the method of substitution. So with elimination, I have 3a minus b equals to 3. And I changed the sign of the first equation, so I made it -2a plus b equals to -1. Then I added these two together. So 3a minus 2a is equal to a, minus b plus b is nothing, and 2 minus 1 is equal to 2. So therefore a is equal to 2. I substituted the a value into the first equation to solve b, and I find that b is equal to 3. Therefore, the a value is equal to 2 and b is equal to 3.